is page replacement algorithm PPT I've shared here. The PPT is visible to all, so let it be known. Is PPT is visible to all?
Yes, sir,
Yes, sir.
visible, sir.
Yes, sir.
Oh, okay, okay. So in the module for the memory management, we have an important topic, that is a page replacement algorithm. So the question comes in our mind, that is what is mean by the page fault in operating system. So before understanding page fault and other things, what is mean by the page, this part we have already discussed into the paging technique, segmentation, and various concepts like memory compaction and segmentation, paging, demand paging, virtual memory. Lots of the topic related to the this page concept we have already discussed, and we have also discussed the what is mean by the logical address, physical address. We have already calculated. So today we have the important part, that is a page replacement algorithm. So I'm going to start this concept very beginning idea, that is by the page fault, and by page replacement algorithm we will use. So what is mean by the page fault? Page fault basically is a action condition. It will happen when the page reference by the CPU is not found in the main memory. Why? Because CPU and main memory are connected with each other directly without any problem, and everything which is stored into the main memory in form of the logical address undoubtedly. So what happened when the page is required? Why page in the main memory? Because main memory use the page for represent the data, while in the physical memory we have the frames, so where the information to be stored. So main memory use a frame, and logical or main memory use the page. So definitely this part is clear to us. When the CPU is required to access the data from the main memory and that it is not found in form of the page, so there is a case or this condition is occur at that time, and that is known as a page fault. So the required page has been brought from the secondary memory to the main memory. Definitely the second point is determining the swapping swap out. So while swapping the data, while swapping or while swapping operation, or while performing the swapping activity or swap out swap in, then page is not found from the main memory through the CPU, then it is found that the data the that is found that we are having the page fault, or we have here some fault and followed by the page, so it is known as the page fault. So a page has to be replaced if all the frames of the main memory are already occupied. So page has to be replaced if all the frames of main memory are already occupied. So at the time page fault of the operating system is required. And how we can do this activity, and what are the various techniques by which we can understand this concept? So there are three different algorithms by which we will see. So now question comes in our mind, sir, what is mean by the page replacement? So page replacement is basically it is a process, and this process can be implemented by some algorithm. So that is why we have the page replacement algorithm. So now page replacement. So page replacement is a process of swapping out an existing page from the frames of the main memory and replacing it with the required page. So when the page fault is occurring, then with the help of the swapping technique, we will replace the current page through the existing page to prevent or to stop the current process. So it is better idea to process or the education must go on. So that's why the page replacement algorithm is better idea. It is just like example of the, if some student is not coming into the specific position, so rather than leaving the vacant seat, it is better idea to occupy the seat by the some other student, and the student is already existed in our class. So it is better idea to replace the seat through the student. And even though we are familiar this term, seats of the student is already occupied, but unfortunately student is not coming to the class due to some reason. Maybe he was suffer from the some disease, or maybe he suffer from the fever. So it is better idea rather than the leaving the seat in the backend form to occupied by the some another student. So same thing we can apply into the our page replacement algorithm. So page replacement algorithm is required when all the frame of the main memory are already occupied. So now keep in mind, frame of the main memory are occupied in the main memory occupied. Then next page has to be replaced to create a room for the required page. So So page has to be replaced to create the room for the required page. So at these two different conditions, we need to use the replacement of the page. So page replacement is necessary or required when the all the frames of the main memory are already occupied. So when the main memory communicate to the physical memory or actual memory, then what happened at that time? The communication between the frame and page may occur during the swapping swap out, but all the frames are already occupied and main memory. So it means the buffer or the area of the memory of the main memory is full. So no other process can be entered into the main memory. At the time page fault may occur, and this is done by the overflow of the pages, overflow of the frames into the memory. So to prevent these things, we have to use the page replacement, and because what happened, that there is no space is available. So at the time of the overflow, we can also note down this condition when the any page is trying to enter into the main memory, but what happened? This memory of the memory of the main memory is full, and what happened at the time? The page tries to enter into its area. Then what happened at the time? The page is not allowed to enter into the its memory or pool area. Then due to the overflow, then what happened? The page is just destroyed or due to this page fault. So this is the one case. Or second case, it is very easy when the page is to be replaced to create the room for the acquired page. So what happened? The another page will come. So and another page will come means the page which is already inside the page which is already inside the room or inside the main memory, because another page is not allowed to come into the main memory because its area is filled up or full, or due to some restriction, we are not able to enter, we are not able to get into the another page into its memory. So this is a drawback, or this is a drawback, but to avoid this drawback, we have the page replacement algorithm. So if we are not able to get the another page into its memory area, so we will manage some page replacement technique internally by the main memory. So that's why we have the page replacement algorithm. Now, these two terms is clear to all: page fault and page replacement. If this is clear to all, then we have the algorithm part. Algorithm is not an algorithm, this is a technique actually, basically. It is a process. And how to manage all the things, so we have the numerical part by which we will see. So let it be clear to me. Is this clear to all, page fault and page replacement concept? Or any
Yes,
doubt you can ask me.
so it's clear.
So in the summarized way, I can speak whenever the problem is occurring while managing the pages, so there's page fault may occur. So to avoid the page fault, so we have to the page replacement algorithm. So I have the few questions here. So I will ask the questions to anyone students. So please keep in mind and please open your eyes or just focus on your eye on the questions as well or algorithm as well. So now here the theoretical, I have a lot of the concept here, but I've just described on a similar way so you can understand. Now, as we know the meaning of the virtual memory, it is like a logical memory. So with logical memory, virtual memory can deal with the frame allocation part and page replacement part. So frame allocation part will be done by the physical memory, and that is recognized by the caution, that is known as the how many frames are to be allocated to the process, and that is determined by the physical memory. And there is a concept which is known as a frame allocation. And with the help of the demand paging and paging scheme, this part we have already discussed, as well as the segmentation. And when they're talking about the page replacement, so which page to be replaced? So the question comes in our mind, sir, page replacement technique in frame allocation concept, where we have to apply it, and this is applied by the physical memory, oh sorry, virtual memory. So we can say the frame allocation and page replacement part is a concept of the virtual memory. So when you're looking for your syllabus as well, this diagram is clearly shown that virtual memory can be understood by the two important concepts. Those are the page replacement and frame allocation. Since frame allocation is not a part of your curriculum, so but summarize way I can speak over here. Frame allocation means that how many frames are to be allocated to the process at the specific time through the physical memory, and the technique is known as the frame allocation in a summarized way. But page replacement is determined at pages to be, or how many pages are required to be replaced at the time the when the main memory dealing with the pages during the process execution. So this is the point where we have, yeah. So theoretically you can read out over here, there are two main aspects of the virtual memory: frame allocation and page replacement. So it is very important to have the optimal frame allocation and page replacement algorithm. So frame allocation is all about the how many frames are to be allocated to the process while the page replacement is to be all about the determining the page number which needs to be replaced in the order to make space for the request pages. So this is the case where we are dealing with. So page replacement algorithm is required whenever we need to communicate to the main memory, and when we need to determine that which page to be replaced. So this page replacement algorithm will help you. So this is a theoretical part. I'm not going to the much detailed part. So we have already discussed lots of the things about this one before at the time of starting the class. So now we need to understand what is mean by the reference string, because with the help of the reference string we will manage our algorithmic part or numerical part of the page replacement algorithm. So string of the memory references, please keep in mind all these words. The string of the memory reference, or I can say the sequence of the memory reference in the order the memory in the memory references values are coming into your pictures. So that is known as the reference string. So reference string are generated artificially or by tracing a given system and recording the address to each memory references. So for this better idea we can take this example, like over here the page size is already familiar, we are familiar with the page size, and a page can be composed by the two important part. One is page number and offset. The offset determines the page size. Okay, so keep in mind this important word. And a page size will not occupy the address of the page. The logical address is a part by which we will determine the page location. But a page can be classified by the or category by partitioned by the two important part. One is a page number and next one is offset. So offset determine the page size, and page number determined by the that is the where the page is stored. And with respect to the page we will communicate to the frame, and this part is done already into the we have seen into the paging system. So if we have the reference of a PHP, PHP means is a value that is P. Yes, hello, hello,
Nine.
hello. Is there a problem, students? Yes, is there a problem?
No, sir. So someone left his mic on, sir. That's why.
Oh, I'm just meeting to all the students by clicking on the one button. Yes, I have done. So with the help of these reference string, we will compute all the page replacement activity. So it is necessary to understand each and every word, because there are lots of the question we have in our mind, that is the, so what is the role of the page size. So what is mean by the page size is different from the page address. Okay. So please do not integrate all these words or with this concept. So here we need to understand properly. So suppose, or if we have a reference to a page P, and then immediately following reference to the page P will never cause a page fault. Page P belongs to the page number and page size is the page size. So this is the point we need to keep in mind when the first page is coming to the memory. So there is no guarantee page fault will occur on the first time, it will not occur. So we need to see what is the size of the page, or we need to see what is the size of the page, and with the help of the page table we will see how many pages can be stored at that time. Suppose taking the example of the page size is suppose 3, oh sorry, 8. So 0 1 0 1 2 3 4 5 6 7 7, it means there are only the 8 pages can come into the page table. So page table represent all these kind of details. So with the help of this page table we can see only the 8 pages are, or 8 pages are able to come into the page table. When new pages try to come enter into a space table, what happens, there is a page fault may occur. So this is a case actually. And how to determine all these things? So with help of the paging we have already discussed all this part. But how to determine all these references? So the example is given here. For example, consider the following sequence of the addresses like 123 215 600 123 476 and 96. All these are the various addresses of the pages, and we can determine this address like over here divided by the 100. This is assumption value and nothing else. Okay, so suppose page size is 100. So how to determine the page reference value? That is better idea. So divide by all these value by the 100. So 123 divided by the 100, so answer will be the 1. 1.23 will be it, but we'll take the only the integer value. So 1 will come into the our picture. 215 divided by the 100, so answer will get the 2. So same things we can over here, the 1 2 6 12 0 0, these are the references value. Okay, these are the memory reference value of the particular pages. So based on the address base and with the help of the page size, we can get the memory references. So when anyone question asked into the examination, sir, how to determine the reference string as we are solving into the page replacement algorithm? So this picture you should be clear. The page references are coming from the very simple equation or simple formula, that is the address which is divided by the size of the page. So what is the address of the page? That is xyz, and what is the size of the address? That is divided by the abc. So xyz divided by abc, and that we will get the some value, and that could be the, that should be in form of the integer. So that's why we have the memory reference string or memory reference value, and that is a 12612 we have over here, and we can have anything. So this is the point we need to keep in mind. And while maintaining the page replacement algorithm, we also need to look for the our page table. So okay, we why? Because there is a fixed size of the page table, and that is also necessary, because how many pages are can come into the one time into that page. Suppose I have the page size 24. Okay, sorry, 16. So what happened at the time? Only the 16 frames can come. If I'm uh, trying to enter 17th picture, I'm trying to force to 17th picture must, or 17th page must come into the my page table. It would not be possible. So this is the case. So this is the idea about the memory reference string. If you have any doubt over here, so let it be clear to me. So we have seen page fault, page replacement meaning, and reference string. Any doubt over here, you can ask me.
So here 1, 2, 6, 12, these are all page numbers, right?
These are the page, not a page number. Yeah, this is the basically we can say memory difference. Yeah, indirectly we can say this is the page number. Okay, page number. Indirectly we can say page number, because generally what happened, we are finding the page number. So by which we can see this page is fault. So this could indirectly we can say this is a page number. Okay, yeah, I agree with this point. But this could be represented by the memory referencing. So definitely each and everything be represented by the page number itself. So we can say undoubtedly, no problem.
Okay, sir, thank you.
Okay, but even with the help of the these kind of the page number or memory references string value, we will to identify which page is to be occurred. Now see, the 76 and 96 are the two different addresses, but we are getting the page reference string that is 00. So at a time we can't exactly, we can't say the- this page number is just this page number occurring. But with the help of the address of the particular page, we are dealing with the page replacement algorithm. So we can manage with the help of some size, and the size is known as the page size. So we are assuming the size that is 100. You can take any size, but the size should be equal to the frame size. Our this computer system or operating system will need to keep in mind this important point. The page size and frame size must be equal. Somehow we can represent this is a page number. Okay, somehow we can represent this is a page number. Yes.
Yes, sir, thank you.
Okay, so I'm moving to next slide for your betterment. So this is the first in first out. It is FIFO algorithm for the page replacement algorithm. So it is very simple question. So I'm just taking just let me clear. Let me choose pointer, that is P. Okay. So the first in first out, a very most famous algorithm, that is FIFO, that is first in first out. So it is the oldest page in main memory, the one of the to be selected replacement. Please keep in mind, oldest page in the main memory in the is the one which is to be replaced, and it is very easy to implement. So we need to see all this part. So now keep in mind what is the size of the this paging scheme. So we have the 4 0 1 2. So at the time we can store only the 4. So we can say this is the page table where the number of frames or number of pages are coming. That is a maximum 4 pages can come. So different strings are given, that is 0 1 2 0, sorry, 0 2 1 6 4 0 1 0 3 1 2 1. So you can see the reference string are repeatedly again and again, because page may interact with each other again and again due to some due to for process education purpose. Because what happened, there is no guarantee process completely within the one time. So it takes 2 3 or more times for its completion execution, complete execution. So it is necessary pages may come again and again for its execution purpose. What happened, because round robin, okay, now at the time round robin, the first time process is preempted. So what happened, this process will come after the sometimes. So that's why we can say that these are the various pages memory reference string we have over here in form of the short way, in the manner of the simple word like the 0 to 9 we can picking. So that's why for understanding purpose we are having all the page reference string only the single digit. So that's why we are divided by the 100, because page size given that is 100. So now come to the point 0. So 0 is coming here, so we have the 0. Now next page coming, that is 2. Now we have taken here, now 1. So now we will pick the 1. Now 6, 6 will come over here. Now when the 4th is coming, now when the 4 is coming, so what happened at that time? Which one is the oldest? For 0 2 1 6, which one is the oldest? 0. Because 0 was stored previous, 0 was stored the previously than the 2 1 and 6. So definitely 0 is the oldest frame or oldest page, okay, we can say. So this page will be replaced by the new pages, that is the 4. So 0 is replaced by the 4, you can see over here. And now then what happened, 0 is coming. So when the 0 is coming, so which was the oldest among the 4 2 1 and 6, that is a 2. So 2, what happens, 0 will be replaced by here. And then if 3 is coming, 1 is already taken, okay, and then 1. So when looking for 1, this one, what happened at that time, why 1 is not replacing? Because 1 page number 1 is already into the our page table okay. So we will not replace any pages over here. Then now 0, 0 is already into the our this table, so we will not replace one again. Now 3, 3 is not into the our page table. So what happened at the time, which one is the oldest among the 4 0 1 and 6? So that is a noted down, that is a 1. So this 3 will be replaced by the over here. And now again coming is the 1. So what happened, 0. Now in the current situation we have the 4 0 3 and 6. So among the 4 0 3 pages, which one is the oldest one? That is 6. So definitely undoubtedly this page or this part will be replaced. Same thing we can perform for the 2 and 1. So you can note it down, that is a among the 4 0 3 1, which one is the oldest now? That is 4. So definitely 2 will become over here and 1 is already here. So this is our now current sequence, that is a 2031. Now what is mean by the fault rate? So how to determine the fault rate? 9 divided by 12, how we are getting 9 divided by 4? 12, okay, 9 divided by 12, this is the page fault ratio, that is a 0.75. So now what is mean by the 0.75 or 9 by 12? How we are getting these points? Can anyone explain me? Can anyone explain me?
Total number of misses
Yes,
divided by
sir.
total number of attempts.
Yeah, okay. So first we are taking the 0, 2, 1, 6. Okay, then we are taking the 4, and then 0 is already here, so we did not pick. 1 is already here, so we did not pick 0, we did not pick. So then
0
3,
will be replaced by 4, sir.
and then 2 is already here, and then 2 and 1. Yes, now tell me.
Yes, sir.
Yes. Yes, please continue. How we are getting the 9 by 12? That's the point I'm
How we
asking.
are getting?
How we are getting the 9 divided by 12?
fault rate, sir. There are 9 faults, sir, and there are total number of pages is 12, sir. Like say miss plus hit, value is 12, sir.
I agree with this point. Total number of pages are coming into the point in form of the reference string, that is 12. I agree
12.
with this point, but how we are getting the 9? This is the point I'm saying.
Sir, 9, sir. It is, sir, missing, sir, na. So, sir, we
9
have
are
to make.
missing. 9 is missing because what happened? First time it is empty, so 0 will come, 2 will come, 1 will come,
Yes, sir.
and 6 will come,
It's
and the 4 will also come because what happened? 4 is not into the our list, so it will be replaced. Okay, so this is again miss, and now
yes,
in now this, see this case. Now 0 is not into the our list, so that is also replaced. Okay, so this is no problem. But what happened? It is noted down that is after the at the time of the at the time of the looking for the 1 or 0. So 1 and 0 is already into the our table. So what happened here? Here this is a page fault. Page fault means the page is already into the memory and you're looking for that page. So definitely fault may occur because duplication is not allowed, very truly speaking. So at what happened it here 1 and 0 at the time of the 1 and 0. Okay, so at the time of 1 0 what happened? 1 and 0 what happened at that time? Because what happened at that time, it is already into the over this table. So page fault will occur. Okay, so we will not count this point. Now 3 will come, 2 will come, 1 will come, and then 2 will come. Then we are looking for the 1. So what happened at that time? It is already inside our table. So at the last it will not come. So these three, what happened at these three will be discarded, or these three are making our page fault. So what happened? 12 minus 3, that will be the 9. So we are missing the total 9, and total number of we have 12. So we have the 0.75 value for the fault rate. So fault rate is just like equal to the 0.75. So this is the value we are getting. So now this is the first in first out. And how to determine the hit ratio or miss ratio? So I will explain to the next slide, but before jumping over that, let me clear to all. We need to see how many times we are missing the pages. So we are getting the 9 values, and 3 we are hitting. Hitting means what we are hitting means it is already into the pages. So now come to the point. First in first out, that is the FIFO algorithm, is a very easy algorithm, and in which we need to look for the oldest page. Please keep in mind oldest page among the given number of pages into a table. So we have the size that is a 4. So 0 1 0 2 1 6 we can add, but the time 4 we can use, and 4 will be replaced by the 0 because oldest page was the 0. So now this is the idea about the first in first out. Is it clear to all?
So can you
Or any,
repeat the misses part again?
yeah, okay. I'm just clear all this part. Yes. What happened at the time the 0? At the time of 0, 0 will be inserted, no problem. 2, 2 is inserted, no problem. 1, 1 is inserted. 6, 6 will be inserted, undoubtedly, no problem. So here we are missing for the page fault. Means there is no page fault is occurring over here. Now when the 4 is coming, so when the 4 is coming, so it is noted down that is 4 will be replaced by the 0 because 0 is the oldest page. So 0 will be replaced by the our 4. So this is the situation, no problem. Now it is okay, perfect. Now at this level, at this point is clear to you. This point is clear to you.
Yes, sir.
Okay, now I'm just crossing a line over here. Now I am marking line over here. So now this part is clear to all. Now when talking about the 0, when we are enter when we'll see the page 0 is coming to the page table, what happened at the time? Current page table holding the pages are 4216. So this page is not already into the our page table. So we will see 4216 among the 4216. Which one is the oldest page? So definitely 2. So 0 will be replaced by the, sorry, yes, this point is will be replaced by the 2, so that is will be the 0. So 0 will cover the 2, so here we will change over here. So this part is again clear to you? Is it okay? So I'm marking
Yes, sir.
this line was okay,
Yes, sir.
thank you. This one. Now when the page number 1 or reference number 1 is coming into the page table, what happened? This page current we have this point, okay, current this have the this table 4016. So when the 1 is coming, so we are noting down that this page is already inside the page table. So here a page fault is occurring, okay. So here page fault is occurring, so I'm writing in easy way page fault value, that is 1. So here one page fault is occurring, so that is the one value I'm putting here for the my counting number purpose and nothing else. So
Yes, sir.
this is not missing. Again, 0 is
Yes, sir.
coming, so it is already inside the page table. So definitely page fault is occurring. So I'm counting once again. So the 0 plus, sorry, 1 plus 1. So now 1 and 0 is completed. Now 3. 3 is not already into the our page table. So which one is the oldest one? That is a 0161. So among the 4016, which one is the oldest? That is the 1. So 1 will be replaced by the 3. So we have replaced over here. Same thing we have done for the 1. So now among the 4036, which one is the oldest? Definitely 6. So it will be replaced by over here. Same thing we can do perform the 1 and 2 as well. So now 2 is coming over here. But when looking for the 1, so what happened at that time? The one page is already inside the our page table. So 0131. So this page is already exist over here. So what happened? The page fault will occur over here. So this one will be count over here. This 1111 is not a page number. This one is a counter. Okay, so I'm taking the counter for counting the how many page fault is occurring over here. So total number of page fault is 3. So if I need to calculate the fault rate, so how many page fault we have among the these 12, that is a 3. So page fault can be calculated by the number of misses, that is a 12 minus 3 divided by total number of reference. Yeah, yeah, we can say this is a very simple formula. If we need to find a page fault, so total number of it, how many total number of hit we can use, that is that is 3. This is the hit. Hit means a page just setting at the time for the page fault we can say. And total number of references we have 12, and here total number of references we have. So we have need to define. So subtract the page fault total number of page fault, that is 12 minus 3, that is 9, and divide by 12. So we will get the value 0.75. So this is the value we got the page fault, that is a 9 divided by 12, that is a 0.75. So this is the first in first out algorithm. In the page replacement algorithm, one algorithm you understand, then other algorithm you can understand easy way. We have only the 3 algorithms and nothing else. So this is the first algorithm. Now this is the first and simplest algorithm, that is known as the first in first out page replacement algorithm. It is not a I can say truly speaking, it is not algorithm, it is process. So but in the technical term we can say this is algorithm because we are doing some activity in the it is the following by the some certain rules. So definitely we have the algorithm, and the algorithmic step we can take one step in easy way. Oldest page in the main memory to be replaced first. This is the simple concept. Okay, now this part is clear to all. This part is clear to you all.
Yes, sir.
Okay, so I'm just coming to the next problem that is related to the our very beautiful algorithm, that is the first in first out. So our system uses 3 pages frames. Okay, so now what is the given over here? 3 page frame size is given over here. Okay, so now look for the storing the page process page into the main memory. So what is the things is given, that is 3. So you can understand the page table size for understanding purpose, that is 3. So it uses a first in first out page replacement policy. Okay, so assume that all the page frame are initially empty like this one. And what is the total number of page fault you need to find? That will occur while processing the page reference string given below 47617611270. And you need to calculate the hit ratio and miss ratio. So I will explain later on, but first you need to define the page fault. So you can solve at your level within the 5 minutes how many page fault is occurring over here, and what are the last values over here. Please use paper and pen and solve it. I am giving the 5 minutes for solving this question. This is a very simple question. You can use
Okay,
paper
sir.
and pen. Yes,
So
please.
how many
Now,
pages are there? 3. Okay.
yeah. How many pages are coming that into our table? That is a 3.
So page fault is 6.
Okay, in the next slide, I have the solution. So keep your answer in your page. And how many faults we have? Total number of 6 you are saying. Okay. And what is the last value? What is the last number of pages are there?
Sir,
What
fault rate 0.6.
So 172.
no, I just need to know the total. Total. Okay, I get it. What are the last 3 pages are here? So please give me the pages number.
Sir, 127.
1,
So
2.
127 will be there.
7.
Okay, 127 will be there. Okay, I have the solution on the next slide. But before coming out that, you are saying that total number of page fault is 6. Okay.
Yes, sir.
Any student who is having different answer, please let it be know. Yes, any student who is having any different answer, please let it be know. Or all students are getting the same answer. Same answer.
Yes,
So
sir.
okay, now total number of references are given 10. Okay. So what are the sequences are 4 7 6 1 7 6 1 2 7 2. So total number of the references we have 10. Okay. Okay. Now is it clear to all? Now first one is that is 4 is coming. So 4 is over here 7, then 7 and 6 and 6. Okay. There is no problem. Then now 1. Now the next is 1. So 1 is coming. So fourth one was the oldest. So that is to be replaced. Now 7. Now 7 is already into the our list. So this is the page fault. Okay, this is the page fault is occurring. That is 1. Now 6 is already. So this is another page fault is we are having. So 1 is already into this one. So page fault is 3 page fault is occurring over here. Now 2. So 2 will be replaced by 7 because 7 was the oldest. So no problem. 7 will be replaced by the 6 because 6 was the oldest. So undoubtedly there is no problem over here. And 2 and 2 is already here. So like this. So now these are the our we can say hit part. So total number of page fault is occurring over here 6. Okay, now this part is clear to all, or shall I explain once again? Okay, so I am just coming to the calculating the hit and miss also. So total number of page hit by the and total number of reference total number of page hit can be calculated by total number of references. How many references we have? The 6. And how many faults we have? Sorry, total number of references we have the 10 and number of faults we have 6. So this 4. So this 4 is what? This is the 4 is our hit ratio. And you can just find the percentage, then you can determine like the 4 divided by 10. So 40% we can have hit ratio. And miss ratio will be reverse part of this one. So definitely miss ratio can be easily determined by
60%.
1 minus hit ratio, 60%. So this is a simple percent. And this 60% determining the miss ratio. So you can easily find out over here how many times you are missing. 6 times. 1, 2, 3, 4, 5, and 6. Okay, the 6 times we are missing. So we can say 60% we have the 60% we have the miss part. Okay, and total number of hit ratio was the 40%. So these are simple answer, simple questions. Is there any problem here? Then you can ask me. यहाँ पे कोई दिक्कत पूछ लीजिए भाई.
No,
नहीं
sir.
तो फिर मैं आगे आगे एक और एग्जाम बताऊं.
No, sir.
Okay. So now next one is least recently used. What is mean by the least recently used? The page, okay, which is not being used for the longest time into the main memory. Okay, that is least recently used. सबसे कम ज़्यादा यूज़ होने वाला. काफ़ी लंबे से यूज़ नहीं हुआ तो उसको हम क्या करेंगे, रिप्लेस कर देंगे. जो बार बार यूज़ हो रहा है उसको हम रिप्लेस नहीं करेंगे. ओके. So now come to the point. The order of the previous example we have, that is 0, 1, 6, 4, 0, 1, 2, and so on so up to the 1. So now at the first very beginning 0, 2, 1, and 6, there is no problem over here. When the 4 is coming, 4, 2, 1, 6. So 0 from the definitely will be replaced undoubtedly. There is no problem because 0, 1, 2, 6 all are having the same level. So which is not used long period. So 0 is not using the from the long period because it takes around many times compared to the 2, 1, and 6. Okay, if time factor is included over each and every pages, so 0 will take the longest time. Okay, so definitely we can say 0 will be replaced without any problem. So when the 4 is coming, so 0 will be replaced by the 4. When the 0 is coming over here, so 0 is not over here, so definitely among the 4, 2, 1, 6, among the 4, 2, 1, 6, 2 is just having the maximum time, or it is just not used by the not being used for the longest time. So what happened, this will be replaced, so there is no problem over here. Till now there is no problem. Now when the coming the 1, so 1 is already here, so there is no problem. 0, 0 is already here, so there is no problem. Even this 0 is also already here, so 0, 1, 0, there is no problem over here. But when the 3 is coming, so 4, 0, 1, 3, sorry, 4, 0, 1, 6. Among the 4, 0, 1, 6, which one is just not being used by the longest period? So 4 is recently used, no problem. And 2 is
6.
0 is again replacing, and 1 is also, if talking about the 1 and 6, so definitely what happened at the time among the 1 and 6, 1 is already occurred over here. Okay, 1 is already occurred over here. Now see, I'm just marking arrow here, but among the 1 and 6, now the 6 is the uh, phase which is not which is not being used by the longest period, so that will be replaced. So definitely this will be replaced by here, that is 3. Now 0 is already few minutes ago, the 0 is already interfere, and 1 is already interfere undoubtedly, and 3 is already here. Now 1 is coming, so again 1 is no problem. 0 is recently used, and 2 is again recently used, there is no problem. Okay, sorry, 1 is already recently used, 3 is recently used, 0 used. So 4 is the one case. 4 is a case where the it is not being used from the longest period. So 0 is recently used, 1 is recently changed, and 3 is recently used. So what we can say, the this 4 will be replaced by the 2, and 1 is already here, so there is no changes required over here. So the value will be the 0, 2, sorry, 2, 0, 1, 3. So how many faults we are occurring over? That is a 8. Okay. So total number of the missing part is here. That is a 8. 0, 1, 2, 3, 4, 5, 6, 7, 8, and divided by 12. So now we have the value 0.67. Now these are least recently used. Now tell me any problem over here.
No, sir.
Okay. Is there any problem? Yes, ask me because yes, please. Least recently used is meaning only saying that any pages which is not recently used by the longest time. So that is to be replaced and nothing else. Any problem here? Or shall I move ahead?
Sir, move, sir. No problem.
Okay, so I'm just
Sir,
giving another exercise. Yes, please, who is?
so you can continue.
Okay, I'm just going to the my next slide, and you have another exercise. You have to solve it. So I will give you now. It is 12:30. So I will give you 2-3 minutes. So within 2-3 minutes, you have to solve. It's a very simple question. The same question we have into the previous exercise. That is a 476176127. You need to find the total number of page fault. Okay. Okay. Total number of page fault. You need to find. And what is the last value? That is, I'm saying this is the table. Yes, now tell me the total number of page fault. The page fault you can understand by the very simple concept, that is the total number of the things we are doing. Yes, done. Who is completed?
Doing, sir.
Going or
Sir,
searching over the internet?
6.
Yes, sir.
sir, six
Okay.
page fault.
There is a 6 page fault. Okay, I agree this point. Answer we will see on the next slide. And here all the students are required to be very honest. Okay, you are not required to search this question over the internet. It's better idea to solve at your level, whatever you have understand over here. Okay, so the page fault you have saying that is 6. Okay, I agree this point right now, and we will see the answer on the next slide. And what are the last values of the pages? Sequence of the pages?
So 127.
One, okay, 1 to 7. I can write down or top to down or bottom to up. Is no problem. What is the approach you are taking? Is a bottom to up or top to down? It doesn't mean, but the sequence must be same. If you are taking the 7 to 1, then you are counting from the top to down, and you are saying the 1 to 7. It means you are saying from the bottom to up. There's no problem. It is a writing style, nothing else. So you are saying the 1 to 7. Okay, am I right?
Yes, sir.
Yes, sir.
Okay, okay, so 1 to 7 is a sequence of the pages coming into our table. Now, page fault. You are saying 7 to 1 or 1 to 7. Let it be clear. 7 to 1
Yes,
or
sir.
1 to 7. 7 to 1 or 1 to 7.
7 to 1.
Sir, if you
Okay,
light P1, P2, P3 from upside to down, sir, then it will be 1 to 7,
yeah.
na?
Okay, I just what happened? What happened? In this example, I'm taking from the top to down. Okay, no
Top
problem. And in this previous example, it is noted down from the top to, sorry, bottom to down. Okay, it's a writing way. What is the approach you are taking doesn't mean, but if you have the sequence must be same, 7 to 1. Okay, so if I solve this question from the top to down, so sequence will be the 1 to 7. Same thing I'm asking here. What is the order you have right now? It is 7 to 1 or 1 to 7? Yes, tell me what is the order?
1 to 7.
Okay, 1 to 7. It means you are counting from the top to down. No
sir,
problem.
1 to 7.
Okay, I agree this point. Now, what is the hit ratio? Hit ratio is very easy to calculate. The total number of 10 we have and minus 6 we have,
4.
and that is the
0.
40. So 40, 0.4, so we can say that 40% we can. Okay,
Yes, sir.
and the miss ratio will be the 60%. Okay, so solution is over here. Now you can see like 1 to 7 because you are counting from the top to down, or sorry, bottom to up, no problem. The total number of page fault we have the 6, that is equal to the miss ratio. Okay, and in similarly manner we can find the above case, that is the hit ratio was the 40 and miss ratio was the 60, same like the FIFO algorithm. So truly speaking, least recently used and FIFO algorithm are giving the same number of page fault and same number of the hit ratio and miss ratio. Now, next we have the optimal page algorithm, which is the last algorithm for this page replacement algorithm. Since we have the other different algorithm, but I'm focusing on these three different algorithms because these three different algorithms are sufficient to managing the page. So these are the basic or important part. Other than these algorithms, we can use the MRU. MRU stands for the most recently used, and different we have the LIFO, that is last in first out. So you can understand LIFO algorithm for the page replacement in the similar manner of the first in first out, and the same manner of the these recent LRU, you can understand MRU, and so it is a reverse part of the LRU. So MRU is what reverse part of the LRU. In this case, in that case, we need to look for the most recently used. Okay, in the least recently used, we are looking for the least recently used page, but in most recently used, we need to see the most recently used page and nothing else. In same case of first in first out, we can replace by the same concept, that is the last in first out. So in the case of the last in first out, we can use the technique of the FIFO algorithm. So it is better idea to understand these three different algorithm in easy way, and in the MRU and other algorithm which are similar manner, you can understand, you can implement at your level, no problem. Now come to the point of the optimal page replacement algorithm. It is the most usable algorithm for by the most usable algorithm for the page replacement, and it is used by the operating system itself, and that's why it is named given the optimal page replacement algorithm. And why optimal? Because it provides the optimal solution compared to the first in first out, and next one, that is the next one, that was what was that is the least recently used. So compared to the LRU and FIFO, optimal page replacement algorithm is better than the both algorithms. So now come to the point. This algorithm you can solve out an easy way and simple concept. An optimal page replacement algorithm was the lowest page fault rate of the algorithm. As I speaking again, an optimal page replacement algorithm exists, has been called OPT. That is also known as optimal. This OPT is coming from the optimal words, or it is also known as the minimum because it has the minimum page fault, and replace the page that will not use for the longest period of time and use the time when the page is to be used. Okay, so this is the point you need to keep in mind. So what are the reference string we have? That is 0 1 2 6. So at this level there's no problem, and now 4 is coming. So 4 is coming, no problem. So we can say it is little bit replace, it is just showing the reverse part of the little bit showing the reverse part of the recently use. So now why I'm taking the 6? Why I'm taking the 6? Why 6 is replacing over here? Why not 0?
Because it is optimal case.
So Why you can say this is optimal case?
Sir, because it is written here, sir.
Oh.
Sir, because we'll use 0 our next time, but we are not
Yes,
using.
that's yeah. This is the point. If you are looking for the list of the reference string, so it is noted down that is a zero is will be used into the next time as well. Same thing we can go for the one. So one will be used for the our next time as well, and two is also we will use into the next time. So definitely it is usable part. Okay, we will use this fold this page next time. So we can see that six is a part. Uh, six is a number of the page which will not be used into the next time. So we will see
Sir,
this
so,
case. So yes, tell
sir,
me.
so how we get to know that 6 will not be used?
Yeah,
So it is
yeah,
future
yeah,
looking.
in, yeah, definitely. Because what happened when we are performing any algorithm, so in the form of the list, so it will keep the record of the all the reference string into its area. So it will just keep the record of the, or it will keep the track of the each and every page, how many times it will come. So this zero is coming to the one, 1, 2, 3. So zeros will come into three times, and two will come the few times, and one will again come to the sometimes. But six is a page. Six is a page number or a memory reference number. It will not come into the next time, or it will not come into the entire process time. So it will be the it will be replaced first. So this is the optimal case. So this optimality is saying that when you're looking for the optimal page replacement algorithm, so we will see the entire list of the entire reference string, and we will see how many page fault may occur. But how to determine? It will determine by the page sequence number, or because the page number, how many page number will come. So we will make a record that is known as the track. So we will keep the record of into the optimal page replacement algorithm. So this is the case we need to keep in mind. So zero will come definitely come into the next time, that is over, that like over here, and one will come of course without any doubt, and two also will come, but six is only the one case which will not be come. So that is a point we need to keep in mind. So here keep in mind the points 0 1 2 1 6. So among the 0 1 2 6 0 0 1 2 0 2 1 6, so which will be replaced? Definitely 6 will be replaced by the 4, because 4 is coming to the next time. So that will be replaced without any doubt, because 0 will come, 2 will come, and 1 will come. But when looking for the next, that is 0. So 0 is already here. So 1 is already here. 0 is already here. But when talking about the 3, so when we're taking the 3, so you can see 1 and 2 will come. So 0 is come, 2 is come, and 1 is come, and 4. So when see now see come to the point among the 0 2 1 4. So 0 will not come, because 1 2 will come, so we will not touch the 0 1 and 2, and 4 and 0. Now competition will come between the competition will be the between the two values 0 and 4. But it is noted down that 0 is the value which is not being used by the longest period and will not be used next time, so they will be replaced by the 3. So this is a case only. So that's why it is known as the optimal page replacement algorithm. First you need to look for the how many times the value will come, and longest period, if from the longest period is not being used, so that should be replaced. These are two conditions we need to keep in mind while solving the optimal page replacement algorithm. That's why it has the minimum page fault. Okay, so that this is the main reason. This will have only the minimum page replacement page fault. So definitely it will have the good concept for the page replacement algorithm. So that's why it is known as the optimal page replacement algorithm.
Got it, sir.
So why
Yeah,
is 3
okay.
replaced by only 0? Why not 4? Can you repeat that
Yeah,
again?
yeah. I'm saying what happened. Now competition will come between the 0 and 4, but 4 is recently used. Okay, 0 is the value which is not being used by the longest period, so that's why 0 will be replaced. This is the point.
Sir, is it practically implementable?
Yeah,
Sir, it is possible to implement this algorithm?
Yeah. What happened? I'm not pretty sure about, but I have read out an article, a research paper in which written that when you're looking for the optimal page replacement algorithm, most of the algorithm are looking for the optimal page replacement algorithm, but there is no guarantee it is practically or it is truly implemented. So most of the algorithm is following the recently MRU, sorry LRU. LRU is most recently used than FIFO. So the FIFO is just having the own drawback. So what happened? LRU is most better compared to the FIFO. But practically, we're talking for the optimal page deployment. There's no guarantee it is implemented because what happened? Zero is not being used by the longest period, but somehow suddenly after the some times zero page is coming at the time. What happened at the time? So we can't say it is a page at the time the optimal page replacement algorithm is working finely. So practically or truly speaking, it is not a good way. But in the some cases, for understanding purpose for the memory management, we can say it is a better tool by which we can manage the page replacement idea. But at the time of the implementation, it is there is no guarantee it will work finally. And I have read an article. This point is written over there. Okay, so for
So
solving this
it's like
concept,
future looking algorithm in
yeah,
which
yeah,
sir
yeah,
like
yes,
we
yes,
predict the process that will have the higher priority, but it is not
yeah, yeah,
implementable.
yeah. It is no, it is practically for a CC plus program you can implement, but really implementation supported by an operating system that could the Windows, Unix, Linux. So that could be a work. That could be a carried out work where you can work. So this is the we can say this is a research work where you can motivate yourself. Okay, at the last slide, I will try my level best to give you the reference or uh, the point why it is not really implemented. Okay, so I will give you some data. No problem. So let us understand this concept more through an example. So here we have the same example, and please solve it. So I think within the 5 minutes you can solve it. Now you have already understand the FIFO and LRU through this example as well. So you can solve this question with help of the optimal page replacement algorithm you can do.
Sir, 5 hit and 5 miss, sir. 50%.
Okay, how many page fault we have?
Sir, 5.
Yeah, of course it is equal to the miss. Okay, so what are the
Yes.
values which will come here? So definitely size will be 13,
276.
276.
Yes, sir.
From top to down or bottom to up? Please tell me.
Sir, from top to down, P1, P2, P3, 276.
Okay, you are looking for this process from top to down. So what are the values?
276.
276.
Yes, sir.
Those students who are solving this question from bottom to up, so their answer will be the 672. Okay, solution will be given to the next slide.
Sir,
Yes, yes, yes. Yes,
sir,
Anish.
actually, sir, there are two possibilities, sir. Apart from 276, sir, it can be also so that we can replace any of two, sir, in one, two, three, four, five, six, seventh step, sir. So 276 is all right, sir, but we can replace, sir, 6 also. So answer should be, sir,
Answer
172.
answer can be yes. Answer can be better
Yes,
in
sir.
this
There
optimal
will
page
be two
replacement
answers.
algorithm. Answer may vary. This is the point. Okay, this is a good
But, sir,
point. We
hit
can say.
ratio and miss ratio,
Okay,
that will
so
be, sir, same, sir.
it could be that will
Yes,
be
sir.
same because if your algorithm is saying same thing, we can't change the hit ratio or miss ratio, but the number of pieces may variation. This could be the point. Okay. Yes. Solve it or solving any other students who have any problem, please let me know.
So 172.
172. Okay, I'm just coming to the my next slide without wasting much time. Now see this one, the 172, or you can read from the 172. Okay, so right answer is 172.
And 276 also, sir.
Yeah, depends on the situation. Okay, no problem. Now come to the point. So total number of pages of occurring of 5. So undoubtedly the hit ratio or miss ratio will be the 50%. But keep in mind the order. Okay. Fo- 4 will come, 7 will come, 6 will come. So there is no problem over it. 4, 7, and 6. When the 1 will come, so 4 is what happened. 4 is for the longest period is not being used. So that it will be used. But keep in mind the when 1 will come. So undoubtedly 1 will come. 4 will coming. No, 4 will not come. 7 will not come. 6 will not come. So undoubtedly the 1 will replace by the 4. So definitely this point is correct. Now 1 will come the next time. Definitely come here. So we will not replace 1. Now look for the 7 at this level, this level. Now 7. So at the level of the 7. So it is found that we can see among the 6, 7, 1. 6, 7, 1. Which one 7 will come? So there is a fault is occurring. So there is no problem over here. When looking for the 6, 6 is fault is occurring over here. So this part is clear. Till now this part is clear. Now 1. So 1 is already here. So there is no problem over here. Anish, listen carefully over here. You are doing some mistakes. You are doing some mistakes. Okay. And 2. So 2 is the page which is used by over here. So definitely what happened among the 671, which is a value which is longest used. So 6. So definitely 6 will be replaced. Okay. So this is the point you need to keep in mind. So 6 is the value which is longest being used. So definitely we will replace this value because recently 7 will be used by over here. Okay, 7 is being replaced by here and 6 will be replaced by here. So what happened? 6 will be replaced. You can replace. You can also replace the 7 value, but you need to see the point which is the not longest use. Now 7 will use. So 7 will be used. 7 why we will not replace 7 because 7 is a value which will be used by at this level. So 6 is the only one value because competition was between the 7 and 6. But 7 will be used by the next time. So 6 is the only value which is not used by the next time only. So definitely we will replace the 6 value. So 2 will be replaced over here. And same thing 7 will come. 7 there is a page fault. Okay, 1 is already here. 7 will come over, but page fault occurring over here. 2 is here, and 2 is already here, so page fault is occurring over. So this is the sequence 1, 7, 2. The condition may happen when the sequence may change when you are having
Sir,
the equal
sir,
number of chances. But I think this is a better idea. Yes, now
sir,
tell
can you
me.
switch off the mic of BAI 148?
Okay, I'm just doing. Okay, okay. Let me mute. Okay. Yes. Now, so this is the order. 4176 there is no problem. 1 is no problem. 7 is no problem. But 7 we need to see 7 will be used by the next time into our record. Okay. So definitely we will keep this here. But is page fault is occurring here, so no problem. 6 page fault is occurring over here. But we will at the same one. So page fault is occurring over. So there is no problem over here. But at the time of the adding 2, okay, at the time of the 1, at the time of the anything, we have to see 2 is not into the our list. What are the values we have? 6, 7, and 1. But we need to replace this page by the 6, 7, and 1. So which value I should pick? Now 1 is basically recently used, but if talking about the 6 and 7, the competition between the 6 and 7. So we will not change the anything into the 1 part. Now come to the 7 part or 6 values part. 6 is the next could be the next page. Okay, because it is into the our list. So but sorry, 7 6 is the only value which is not a part on our list for the coming page. So we will replace this page. So that's why it is replaced over here. And 7 is occurring fault and 2 is occurring fault. This is the sequences. That's why we have the sequence hit ratio 50% and miss ratio 50% because total number of PS fault is occurring that is equal to the miss ratio or miss total number of misses part. So that is the 5. So we have the 50% among the total number of the references. Those are the 10. So 5 divided by 10. So we got the value 50%. So now this is the solution. Okay, this part is clear to all. So what is mean by the piece replacement and what are the various techniques by which we are doing? So those are techniques are recognized by the 3 different techniques, first in, first out, and next we have the LRU, next we have the optimal. Now, any doubt over here?
Excuse me, sir.
Yes, please.
Sir,
Yes, ask
why
me.
in the fourth column we have replaced 4 instead of 6?
Where?
Means 6 in the fourth column, sir.
1, 2, 3, 4, 6.
Sir, means
One is
4.
replaced.
Yes, sir, 4.
No, no,
6
no, no,
have to
no,
be
no, 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 no. No, no, no. 476. Actually, we are reading the value from bottom to up. Actually, please keep in mind this point,
yes,
and then
sir.
see the answer. So
So, but
4 will
6 is
come
the
over here.
most recently used, no, sir? 6. Then we should
Six is
replace 6.
This is
6 is
optimal
more
case.
recently used, but no. 6 is most recently used, but fourth is a value which is not being longest used. So definitely 4
Yes.
will be replaced. Please read this point. Okay, please read the word.
Yes.
Replace the page that will not be used for the longest period of time. Okay, keep in mind this point. So that's why this one will be replaced by sorry, yeah, one will be replaced by the 4. So we will replace this 4 value by the 1 value. So we have changed it. भाई 4 यूज नहीं हो रहा ना काफी टाइम से, तो 4 को 1 से रिप्लेस कर दिया. 6 अभी रिसेंटली हुआ है, उसको चेंज नहीं करेंगे. 7 को किया है, वो नहीं करेंगे. 6 से 7 4 में से सबसे ज्यादा कौन सा यूज नहीं हो रहा है? 4 यूज नहीं हो रहा है, तो उसको रिप्लेस कर दिया. सो हमने यहाँ पे कर दिया 671. 7 ऑलरेडी है, 6 है तो फॉल्ट नहीं हो रहा, फॉल्ट हो रहा है तो कोई दिक्कत नहीं, हम एज इट इज रखेंगे. 1 को देखा फॉल्ट हो रहा है तो एज इट इज रखा. पर जब 2 की बारी आएगी तो कंपटीशन ये आ रहा है कि 6 को रखें या 6 7 को करें, क्योंकि 1 तो रिसेंटली यूज हुआ है तो हम इसको चेंज नहीं कर सकते. ठीक है, अब बात आ रही है 6 और 7 की, वही बहुत टाइम से वो चल रहे हैं. तो अब 7 की बात करेंगे और 6 की बात करेंगे. तो पर ये नोट करा कि 7 एक ऐसा पेज है, नंबर है जो हमारे रिकॉर्ड में है, हमारे ट्रैक में है, तो इसको हम क्या काम करेंगे जो यूज होगा आगे आके, तो हम इसको नहीं करेंगे. फिर हमारे पास कौन सा बचा? 6. ठीक है, तो इस 6 को हम रिप्लेस कर देंगे 2 से. तो दैट्स व्हाई द हियर वी हैव द सीक्वेंस 2 7 1, और वी कैन से रीड आउट फ्रॉम द bottom 2 up. So 1 2 7, and then 7 is already placed here, and 1 is 2 is already here. So that's why we have the total number miss 4 and total number of hit, that is a 5. Now it is clear to all.
Yes, sir.
So any doubt over here, then you can ask me, please. So this is a page replacement algorithm. So why we are studying the page replacement algorithm? Because into the main memory, if the memory is full, then page is trying to enter. So what happened? New page will not be entered because its size is filled up. So internally it will deal with its own number of pages. So this will be occurred when the we are dealing with the swapping concept. So while swapping, definitely the page fault may occur. To manage the page fault, so it is better idea to use the technique that is known as the page replacement. So why page replacement algorithm we are using? To manage the page fault, we have to study the page replacement algorithm, and those are the 3 important techniques or process or idea or approach we have. Those are the first in first out, LRU, and last one we have, that is the optimal. Okay, so optimal page replacement algorithm. In the replace of the LRU into the examination, anyone or may I can ask I can ask you like the MRU, like most recently used. So that is the reverse part of the LRU. So you need to understand what the question is asking. So these are the various technique which we can follow, and we can use the LIFO, that is last in first out. Okay, so this is the very simple technique by which we can follow the page replacement algorithm. So for the enhance the complexity of the numerical, anyone can use any kind of the idea. So explain the LIFO technique for page replacement. So what happened? सर आपने तो नहीं पढ़ाया है, कैसे कराया है? सो वो उसका कुछ नहीं है। जब हम फर्स्ट इन फर्स्ट आउट देख रहे हैं वो लास्ट इन फर्स्ट आउट देख लेंगे। जो पहली आपकी आई हुई थी, जो पहली आई हुई थी, तो हम उसको ओल्डेस्ट को ले रहे थे। हम उसमें क्या करेंगे, लास्ट इन फर्स्ट आउट में डेट वी विल टेक द रिसेंटली यूज एंड नथिंग एल्स। And when the pairs are fault, so there is no changes over here. So this is a simple technique and nothing else. So you can solve this kind of the question in easy way, but you need to understand the point what the question is asking. Okay, now this point is clear to all.
Yes, sir.
If you have any problem here, then you can ask.
So that fourth algorithm is called what, sir? Lilo.
LIFO MRU.
LIFO.
LIFO
Last
LIFO
in,
stand for
first
the
out. Okay.
last in first out, and
Sir, is there
next we have
something
the it is
last in, last out?
equivalent to the yeah it may last in, yeah definitely we have the another part that is the last in Lilo. Lilo is a technique which is also used by the page replacement. So in this case, what happened? We need to use the last in and last out. So in this
Last
case,
out.
what happened? We need to what happened? Most recently used is different from the last in last out. So the value which is coming to the our page number of pages of page table. So last in which is to be used last time, that is last out, and last in
Sir,
first out
but
is different from the
hello.
क्या क्या
Sir, but sir, first in, first out is different from last in, last out. How, sir?
फर्स्ट इन फर्स्ट आउट हो गई आपकी, जो पहले आएगी वो पहले जाएगी।
और
ठीक
सर
है
जो लास्ट में आएगी वो लास्ट में जाएगी, तो बात तो एक ही हुआ ना सर।
ना 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 लास्ट का मतलब हो गया जो रिसेंटली आई है।
ओके ओके।
सर
फर्स्ट इन
बात
फर्स्ट
वही
आउट नहीं नहीं, फर्स्ट इन फर्स्ट आउट यू आर टॉकिंग अबाउट द ओल्डेस्ट, एंड यू आर टॉकिंग अबाउट द लास्ट इन लास्ट आउट, यू आर टॉकिंग अबाउट द रिसेंट जो करंट में अभी लास्ट इन आए हैं। हाँ मतलब ऐसे कह सकते हो, लास्ट इन मतलब उस वो में देखा जाए तो जो लास्ट इन हुई थी और लास्ट आउट हो रही है, हाँ वो कह सकते हो, बात घूम के वही निकलेगी।
यस सर।
But yeah, but LIFO is different from the first in first out.
फर्स्ट इन, फर्स्ट आउट, यस सर।
Okay, so this kind of the question may ask into examination for the confusing purpose, nothing else. So what happened? Last in first out is different from the first in first out. So to be remember the my memory, I'm just remembering the few techniques. Those are the last in first out and MRU. But I am not discussing MRU and last in first out because into the examination most of the questions are asked based on the FIFO, LRU, and the important part that is optimal. Optimal based question may ask in the examination most percent, maybe most chances. Why? Because of for confusing purpose. Because it is a good approach in the various way. Most of the algorithm is having this idea. That's why the optimal based question may ask into the. But for confusing purpose, into the examination, LRU can transform into the MRU. So based on the LRU MRU technique, will ask. So this is the only the technique, this is the idea. So you need to use your idea to understand the concept and implement into your page replacement algorithm and nothing else. So this is the general way. Yeah, I agree with this point. Last in last out and first out is same meaning, but last in first out is different from the first in first out. So five techniques are available. Those are FIFO, optimal, LRU, MRU, and LIFO. So these are the five techniques, but I am not discussing the LIFO and MRU because it is just equivalent to the LRU and first in first out. Okay. So is there any problem over here in these three techniques? You can ask me. If you don't have, then we can close the class or we can stop the class right now. Yes, please, anyone?
No, sir.
No, any student is just, I think, okay. Yes, no problem. So I think it is better idea to leave now. Huh?
Yes sir.